All right, so here you go. We are kind of the first week of the school. So um, I know some of you already know my name, but this is my name. Okay, this is my name. And you see that I'm recording my lecture right now because you're going to see this one on YouTube channel this semester. So meaning, let me tell you my email address first. This is my email address. You guys already know this, but just J and my last name. This is my first name James. So J and short. So anyway, so we're in group B, right? Part B. So we're in part B or group B. Okay. So once again, we're all meeting on Fridays. Okay, Fridays. So this is our first meeting in class this semester for the group B. And next in class meeting will be next Friday. So you only coming to in class, in person lecture Fridays this semester. Makes sense, right? This is what I did for previous semester because the last semester was also about COVID-19 semester. So we're gonna do the similar class setting too, but here's a little small change. What I'm gonna do is this one. We have only group, so we are in group B, okay? But Wednesdays, there will be part A or group A people will come to in class, attend the class on Wednesdays. They come on the Wednesdays, okay? And then, what about the Mondays, okay? What about Monday? Monday is open spot. So I'll be here on Mondays as well in class. But if you want to take maybe twice or even more times in class, in-person lecture during the week, you can also try to come to Monday lecture as well. But here's the thing. Class capacity for this room is 18. Okay, I assume we are in 17 here and 18 now. So if you actually enrolled today or yesterday, just let me know after class. But anyway, means we are free full in this Friday or Wednesday lecture limitation. So you can come to Monday lecture, but to be honest, you need to compete with group A. Okay? So if you don't see any spot, you cannot attend it. But if you want, you can try to come to the lecture early. So you can also might have a chance to listen to me in lecture in real time, in person, even on Mondays. So they will give you more chance to do some in-person real-time lecture if you want to. But here's the thing. Technically speaking, oh, there's a spot over there. Technically speaking, attendance is not required for your grade. Okay? If you don't come to the lecture even on Fridays, that's okay. You just need to make sure you go to YouTube channel and see my recorded online videos. There you're not missing anything. But if you come to next Friday and after, or the Fridays after, you'll get a chance to get extra credits after every Friday lecture if you are in group B. So you don't have to come if you don't want, if you don't need extra credits, and if you want to actually learn chemistry through online platform, that's totally fine. It's your choice, right? Because attendance is not required for your grade, but only for extra credit, which is what? Additional points. You may not need anyway, okay? Makes sense, right? But if you come, you get the extra credit chance. So you do some little bit of small activity, you get the extra credit every Friday if you come to the lecture, okay? So anyway, once again, Mondays, because of this one, some people just don't want to come to the lecture. They This is their preferred way to learn chemistry in this COVID-19 semester. So I think if you try, you would have a pretty good chance to find a spot in the open Mondays. So this is something you can do if you want, and this is kind of a not so good chance, but you can also shoot for Wednesdays too. So same reason here. You want to attend the Mondays, you can go there and try compete with the group A, and you definitely come here to get just in class, in-person lecture, but also the extra credit. For the same reason, there might be some open spot too on Wednesdays, because I promise you, not all students will come on every Wednesday or Friday, because they might have some other things they need to attend to.
Will there be different lectures on Wednesday and
Friday? No, all different lectures.
Okay.
So, but once again, if you don't come to the lecture, just make sure you watch that recorded online video posted on the YouTube channel later that day, because it takes a bit of a time for me to upload it on the YouTube, which is, you know how big this file is every time? It's 4 gigabytes. So it takes quite a time for me to upload this big file every time. And so it takes a little bit of time, but if you don't come to the lecture, it's okay. You don't have to worry about anything, but you just need to make sure that you go to YouTube channel. I'm gonna put the YouTube channel link on the Canvas today, so you can find it later anyway. But make sure you guys go there, watch the online video. Here's one thing, to be honest, I want to tell you. That is, when I did the last semester, I can see the view on each YouTube channel that I posted on the YouTube channel. But it doesn't go out like almost the same day, but later, close to the exam day. Meaning, sometimes you don't have enough time. You're just kind of cramming everything into the exam preparation in a certain day, which is not so good way, I personally believe. Some people can do it. It's okay, but I can definitely tell you, if you miss the lecture in person or in class, then it's really important to watch the video on that day though, because if you don't keep up with all the progress that we make every week, especially for Orgo 1, if you just don't follow the first lecture, there's almost no way you can possibly understand the second lecture, because it's all sequential process. So if you miss in class a lecture, just make sure at least you go watch the online video at least once. But it's up to you guys actually. I cannot force you. But I strongly personally believe that is the one way you can do for succeeding in this course. Makes sense, right? It's pretty much everything you already know, but I'm just gonna reminding you. Okay? All right. So anyway, so you can shoot for the Mondays too. Maybe still some students will not come. If you see any open spots, if you wander in the hallway for other class or something, you can also try. I'm not gonna prevent you from taking this one either if there's an open spot. But if there's an open spot, there's nothing we can do. But it makes sense, right? So possibly, if you really want, you can almost have a 3 in-class lecture every week if you try. But at least 1 for sure with extra credit. And also, you can watch the recorded online video on YouTube channel anyway. But if you feel like that's not a good or efficient way for you to learn about organic chemistry, you can definitely try. If you still don't have many open spots on the other days and the week, there's another thing I can also recommend is you can actually come to my office. So my office is this building, 2nd floor, MSCX 215. Okay, so I normally open for almost all time block on Thursdays. I'm always there's a lot of time for me on Thursdays, so you can almost come any time block here. I'm really busy on the Fridays and Tuesday. Okay, So I'm really busy on those 2 days. So maybe it's not so good day for you to just knock my office door and see me. But Mondays and Wednesdays, you can definitely see me after 2 p.m. in office. Okay. So yeah, that's it, right? Yeah. So if you can find a good time for making those two, except your regular in class time, which is Fridays. So next in class, your regular class meeting will be next Friday. Okay. Anyway, right. You can still try to shoot for those two, but if you still need a little bit more help, you need more like a in-person help, or I can definitely do it in my office with the social distancing. I bought a new like a whiteboard, so I can show you from the distance. You can definitely see, but this is something that you can try. Okay, makes sense, right? Right. So, do you have any questions? It's pretty clear, right? Okay, perfect. So, this is something we're gonna do this semester. So, most importantly, let me explain about the grading system. Okay. I think here's the thing. So we're gonna have 2 midterm exams. Only 2, not 3, 2. Okay. And we're gonna have 1 final exam. Okay. And we're gonna have homework too. It's online homework. Okay, there's a online homework too. Each midterm exam will be worth of 100 points. So there will be in total what? 200 points, right? There will be 2 midterm exams. And the final exam is comprehensive. It covers all the chapters, and it's quite important. So it's 200 points. Okay. And your online homework, here's the thing. Only thing you need to have for this course is a textbook. This is you can see that on the syllabus, but you can buy either 18th, is it 18th? Oh, 18th edition or 19th, doesn't matter. I see the 19th edition is with the white cover with the flower. The 18th is actually the black color cover with the flower too. But either way, it's fine. So only thing you have to have for this course is textbook, because I'm not gonna let you do the regular our old online homework platform, which is great. But in this semester, I'm gonna try the new things. So you're gonna do Canvas quiz. So Canvas online homeworks. So only thing you have to do is if you go to Canvas homepage, I'm gonna sooner or later open up one of your tab menu. You don't see it right now, but I'll open it for you. There will be says quiz. It says quizzes over here. Okay. And then if you just click, and you'll see the list of the Canvas quiz. So you just click and you just solve the problem until the deadline I set on the online homeworks there. And those one will in total 100 points. Okay. So the reason why I'm doing this is the other online software platform we've been using is great, but when I create some like exams for this course, it's kind of in a different format. Because in online, the best part is you can actually look at the 3D models of the compounds. You can actually see how it works, and you can also draw the additional bonding and everything, which is possible in 3D, semi-3D press space in the online platform, but in exam, we cannot do it. You're going to do this on 2D. So whenever I do the Canvas online homeworks, maybe every chapter or so forth, I'm not going to lie, this is very important. The questions you see on this quiz will be very similar to what you see on the exam. So do not just try to earn the points there. Try to remember this format or the questions. So you'll be much more familiar with the questions you may see on the exams. So this is one tip I can give you, and this is why I'm trying to do this at this semester. This is kind of new thing I'm trying. This is my first time, but I'm still certain that this will help you a lot, because you already know at least some part of the exam will be like what format anyway already. Okay, makes sense, right? So make sure you guys remember this. So in total, you're going to have 500 points. Okay, 500 points, right? So it's pretty much the same. If you get above 90% A, or above 80% B, 70 C, and so on, but this guarantee letter grades. I normally do, historically speaking, I normally do at least a little bit of curve anyway. You actually have a better idea over the semester later, but basically it's just the 500s, so meaning what? If you get more than 450, it will be A, 400 B or something, guaranteed. But we'll see how we can do at the end of the semester. Makes sense, right? Okay. So there's one more thing I want to tell you, which you will love it, which we happened so positively last semester too, is this one. So I know some of you, study hard, but I'm not gonna lie, organic chemistry is not an easy subject. I totally understand. Like other, field of study, it's all kind of, we need to spend some time and efforts to really have a good understanding of something and topics, especially also in this one as well too. So organic chemistry is not an easy subject, obviously, like others. But I do understand it takes some time. So maybe you try the midterm exam 1 and you got 50 out of 100. Okay, that's unfortunately you had 50. Okay, and then the second exam you did better because you have a better understanding over time. You said, oh, now I think I'm getting it or something. So now you have 80 over here. Okay, so that's pretty good actually. And then finally, at the end of semester, we're gonna have a final exam, which is 200 points. But you did really well. So let's say we have 190 for the final exam. And if that happens, you already saw this in the syllabus yesterday. If you saw, but if this happens, what I do is I'm gonna put this in the person score, which is 95%, right, out of 200. So this 95% will replace your lower midterm grade exam score. So this will be 95. So that's definitely an A. So you don't have to worry about one of the midterm exam score if you didn't do well. So for this reason, you don't even have to worry about missing one of them. So even though you get 0 over here, because you didn't even come to that lecture for some family emergency, medical condition, medical excuse, all the good excuse, you cannot come. Or to be honest, if you just don't come, doesn't matter, because you have a final exam will replace the low one. So this is why I don't normally do the makeup exams, but what happens to this one really is when I did it over like years and years, lots of it's already proven to me that it works so well that so many students did really well on the final, and they got much better grade than they expected at the beginning of the semester. And it happened so many times, not every single semester. So I'll always keep this grading system in the syllabus every semester. It makes sense, right? Do you know now how it works, right? So technically, you're going to have a chance to do well in this course in the last minute of the semester, because your final exam is really, really big game changer, which will eventually change 300 points out of 500 points. It changed a lot, and it did happen so many times in previous semesters. Okay, can you trust me? It really happened. So this is something we're gonna do here. So that's pretty much it, I think. So do you have any questions about anything I talked to you today? About the class, anything? It all kind of sounds clear, right? You can also double check this one on the syllabus. When you read the syllabus on Canvas, you would definitely double check all the things that I said today. But just let me know if you have any questions even after class, okay? All right, so we have a little bit of time. So let me go over a little bit of, here's one thing I asked in Wednesday Group A students too, that Chapter 1 of the Orgo 1 chemistry is usually just a review of what you already learned in Jenkins 1 and 2. But do you also want me to do all the review, right? Before we really hitting on the real organic chemistry, right? Okay. So let's start with some of the things we have learned in the previous chemistry course here. Okay. So you can, yeah. All right. So whenever you look at the organic chemistry, it's simply we're going to learn and we try to analyze how those compounds will work in chemical reactions. Okay, chemical reactions. And then those compounds are mainly composed of carbon and hydrogen. Well, you can just say carbon, but we can, well, in general, carbon and hydrogen. If we have some compounds mainly made of or composed of the carbon and hydrogen, those molecules we can commonly find, especially in living organisms and in the nature. We'll see some of the chemical reactions they do, and we try to analyze why is it happening, how it works, and what's the point, what's the takeaway, and everything. Okay, so let's talk about why is the carbon hydrogen so special and unique over here. One way to answer this question is when you look at the periodic table, the carbon is right in the middle because you know how to read a periodic table now, right? So if you go from the top to the bottom, all period, like a first and second and third, the carbon is in the what? Second period, right? So we can second row, and we have 1, 2, so 1, 2, 3, 4, right? 5, 6, 7, 8, right? So carbon is right in the middle. So this is group 4. Okay, so this is quite free from the being easily ionized, meaning it's not metal, so it won't be easily positively charged, but it's not close to the way you can find the halogens and other noble gas, so they won't be easily negatively charged. They're only going to go through those like carbocation, carbon anion. You're going to learn later this semester, only in a certain conditions. So relatively speaking, they're quite stable, and also they're relatively speaking quite common because do you know what is the most abundant elements in the universe?
Stars.
Yeah. You see what's in the top left corner in the periodic table? Hydrogen. So this is also why you see a lot of hydrogens over in organic compound. Anyway, and also helium too. But carbon is relatively speaking also quite small element among others too. So it's quite abundant, relatively speaking. Not as much as those two, obviously, but it's quite somewhere, chemically speaking, stable in terms of the octet rule and everything. So this is why the carbon hydrogen becomes so critical, so important for this lot of compound chemical interactions. And we made one field of study about it, which we call organic chemistry, because also carbon and hydrogen is the main thing you see in the nature in a living organism too. Makes sense, right? Do I speak too fast?
You're good.
You're good? Oh, perfect. I guess. Awesome. All right. So, but then this is the case. There's certain things I want to review that we from what we learned already from Jenkins 1 and 2. So, if you remember, the first thing you need to know about, when you try to think about the carbon and hydrogen is the S and P orbitals. Okay, you guys remember this, right? S and P orbital over here. So let's try to get a little bit of basic information about this one. So if you look at the quantum numbers, the first one you need to know is the principal quantum numbers. Quantum number. This is n. Okay. So this actually represents the energy level. I'm gonna write it. Energy level of your orbitals. Okay. And also the eventually electrons in orbital too, but vice versa. So, and also the distance of the orbital, like size, and also the electrons in the orbitals from nucleus. Okay, so try to remember the atomic model here, right? You have a nucleus at the center, right? You're gonna have electrons are kind of moving here, but this is kind of a Bohr model, right? Kind of classical model. So in more like a modern chemistry, modern physics, we more into kind of a cloud system. I don't know if you heard in Jenkins 1. So that meaning we're actually going to see the kind of using electron density instead of using just where the electron is. Because now we look at the electron as like kind of a standing wave. Do you guys remember this? So only thing you have to know is that orbital is the way you can find the electron by high chance. You remember this one, right? Using wave function, everything, okay? But you guys remember n, right? Though n. So n always start with the 1, 2, and 3, not 0, because 0 is where you can find the nucleus. How can you find the electron in the nucleus, right? So that's why we don't have 0 here. We do 1, 2, 3 because we believe that those are quantized. It's not continuous energy level, but it's a certain energy level is quantized. So they can move on to either 1, 2, 3, not 1.2, 1.3, 1.4. No. Okay? You guys remember this? Okay, good. Just let me know if you have any questions. So later on, you're gonna learn about angular quantum numbers, which is L, okay, which will determine the shape. So this will determine the shape of your orbitals, right? So angular quantum number is simply this one. The way you can find the electron distributed in the space, but if there is a certain angle, it will actually make the certain space where you can find the easily electron. So if you have L is 0, what orbital is this one? S, right? S orbital, okay? Do you know what it looks like, S orbital? It looks like sphere, right? Perfect. Because there's no much of angular quantum property there. So there's no particular shape, but just all evenly same. So it's a sphere. Makes sense, right? Because there's nothing there. But if you go to 1, so now they have a certain angle, a certain way to distribute the electron in the space, not evenly. That's why this is the p orbital. It looks like, there you go. So they always line up with what? Certain coordinates, right? X, Y, Z. So that's why it's 1 that makes dumbbell shape, because you have some angular quantum property that lines up with each coordinate axis there. So x, y, z, either they can go 1, 2, or 3. Okay? So this is why later you're gonna do. Okay, I'll do the later. Anyway, so now that's why it looks like a dumbbell shape. Okay? So when it's 2, now it's what? D, right? Perfect. D orbital. Okay. D orbital. Now it has 2. That's why whenever you look at the coordinates, it has butterfly. Now it's 2. Right? It's pretty easy, right? And now if you switch it to the 3, which is F orbital, you're going to have 3. No, I'm sorry. Let me do. F is always the harder one. There you go. Okay. This is a one common. There's other like a wing. If you have a wing, the count is 2. So the F orbital will be there with 2, something like this. But you don't have to know. But what you really need to know is why we have a certain shape of orbital. This play lots of different rule on organic chemistry. It's very important to know. Okay, makes sense, right? Alright. So the third one is the. Can you guys guess? Third one, magnetic, right? Magnetic quantum numbers. So think about it. Of course, if you're distributing certain, electrons in the space by certain chance, not like a certain exact location, they probably have some kind of magnetic quantum property over there too. Meaning, now we know how it looks like and how big the orbital is, but we don't know how it can lay on the space. So, for example, p orbital. They can either go to this way, or you can lay on this way vertically, or on the other axis over here too. So that depends on the magnetic quantum property over there. Because each different p orbital can have a different magnetic orientational force. So they determine either they can lay on here, if this is more preferred here and here. So it actually determines how is it oriented, where it lays on the space. Like it's like a 90 degree, 80 degree, or in a other axis here. So we call this M or ML, like a small subscript L over here. This is why if your L is 0, there's no orientation of the sphere because it looks sphere anyway, right? So that's why just only 1, 0, 1 over here. If L is 1, ML will become -1, 0, and 1 because that's 1. Okay? And goes on 2. L is 2. ML will have a -2, -1, 1, and 2. And 3. ML 3. -2, -1, 0, 1, 2, 3. So you're going to have, it kind of makes sense. You have more numbers of angular property in your orbital that gives more different way for them to be laid on the space. Right? Okay. So that's why if there is a 0, only 1, there'll be L is 1, there'll be 3. If there's 2, 5. There's 3 and 7. This is kind of so if you look at the principal quantum number and angular and magnetic quantum numbers are for, technically speaking, orbitals. But you can also say this for the electron, because orbital itself, its definition is what? Just the A 3D space where you can find the electron by Huygens. So it's pretty much the interchangeably can be used, but precisely those 3 numbers are for orbitals actually. But the last one is the MS. You guys remember this, right? It's magnetic spin, right? So this is magnetic spin. This is for electron itself, not the orbital. This is purely for the electrons, because whenever you think about here's the thing. If you look at the atomic model, either it's classic or modern, you'll see the interaction between electrons and the nucleus, because nucleus is made of what? Protons and neutrons, right? The proton is positively charged. As we all know, the electron is negatively charged. And obviously, they're going to have some interactions there, right? But whenever you look at each orbital, like if this is a p orbital, in each box or diagram of your p orbital, how many electrons can be filled in there? 2, perfect. They go, one is up, 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 and down, 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 right? Because to explain that this is just very stable, but sometimes you have this one which is unstable but is possible. So this is why they wanted to make up spin and down spin, which is plus and minus half. Okay, so this is about their. This is kind of a classical approach to understand the electrons in the atom, meaning they actually given the electron itself has a bit of a motion, like so it's a very classical approach. But in that way, we can express the only one electron in a box in certain condition, no problem. So this is kind of something we had to apply to explain the Pauli exclusion rule in Jenkins 1. Okay, so this is something that I want you to remember before we move on to any part of organic chemistry material, especially S and P orbital. Okay, but it all makes sense, right? Do you have any questions? You good? Okay, perfect. So here's a couple of things we can talk about. Is this one? So obviously, well, we're gonna have some the bondings in organic compounds, but there's a couple of things I want you to remember. Is this one? You have a carbon here, okay? You have a hydrogen over here, and the best way for you to understand this is to think about the Lewis structure. You guys remember the Lewis structure in Jenkins 2? So we're actually going to put some numbers of valence electrons. Okay, so carbon is group 4, right? So it's group 4. So I'm gonna put the 4 electrons around the carbon over here. Okay, and then I'm gonna put only 1 electron around the hydrogen because it's group 1. Okay, so in that way, what they normally do is they try to make covalent bonds. Okay? Covalent bond. Okay, it's simply just what it says. Really, because it's co means together, right? Valence is what? Adjective form of valence, which is your valence electrons, right? So if you share, there's each one valence electron from carbon and also hydrogen, they can make a bond here, which is literally covalent bonds. Okay, so you're sharing each valence electron from carbon and hydrogen, they make a quite strong bond together. So this is what we call this covalent bond here. Okay, so maybe you can do this to here, 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 here. Okay, so this will make methane. This is very smallest organic compound you can think of. So if you have this one over here, one thing I want to point out is I want you to remember hybrid orbitals here. So like I said, if you look at you know how to do electric configuration, right? Right? So basically, I know you guys sometimes do this one, okay? But I don't think it's a very good way to do it. You know, like you remember this? But best way for you I think each exam you're gonna have a periodic table. So if you look at the periodic table, this is the first two column is the s orbital here, okay, and then later you have a d block here. You have a p, okay, over here. There's one s actually, and then there's the p block over here, okay. So if you look at the over there, it would be 1 s 1 2. 2, second row would be 2, right? 2s 1 2, and that's the 2p over there. So 2p 1 2 3 4 5 6, and 3s 3p and 4s. And only thing you need to remember is it becomes the 3d because of the 2 and square rule we learned thinking about. Anyway, so based on that one, carbon is what? If you period 1 is perfect. 1 is 2.
2s2.
Perfect.
2p.
2p2. Perfect. Excellent. But this is what? Inner electrons, right? They're already in the dual role, so we cannot use the electrons, right? So we can only use over here, right? Okay. So this is why we have a 2 in s orbital, 2 in p orbital here. If that is true, the bond length and the nature of those bonds should be different, right? Because the 2 of electrons in carbon is s orbital, 2 of the carbon electrons in the carbon will be p orbital. So if that is true, because hydrogen is always going to be what? S. It's always sphere, but those two in the p dumbbell shape, those two in the sphere. So if they make a bond, those nature of the two bond has to be different, right? But when we experimentally find out the bond length from those four, it's all equal because of what? Hybridization. So that's why this is also important to understand in organic chemistry. So make sure whenever you have a carbon here, okay, you always think about it is going to be sp3, sp2, or sp1. Okay, this is very important. So if you look at, so here's the thing. Whenever you look at the 1s is down here, okay. Okay, so we don't have to worry about this one because it's very, it's very stable already. So you don't want to use the electron that is already in stable form. But the one in here, which you can possibly use, right? But what they do is they become sp3 and all in the same energy level. Okay, like this. Okay, so that is the kind of you're hybriding the S and P orbital together. But if you can do it, sometimes you're leaving one on the P, and you just make it sp2, okay? Or you can make it just sp and make a 2 p orbitals in upper p orbital diagram. Then the point is, if you look at the sp3, they can be all used up for making bond to the other elements, maybe hydrogen, oxygen, nitrogen, you name it. But in sp2 and sp1 is only happening when it's in double bonds, and the sp1 is happening in triple bonds. Here's the reason why. Oh wow. Okay. So whenever does it make sense? So far so good? Yeah, go ahead.
So anytime there's a carbon bond with a
anything
double covalent, it's always going to be sp2?
Yes, the double bond, not always. Okay, here's the thing. But most likely, yes. But the point is, you're not talking about what? Hydrogen or anything, but carbon. So when I ask you about the hybrid orbitals, it's all for carbons. Okay? So the reason why we're doing this is whenever you have a carbon, maybe carbon interaction over here, this is what happens when it's hybridized. because this the sp3 is it looks like a P, right? Because it has a 75% P shape, only 25% spear shape, because it's a hybrid in different order. So they have a little bit of different shape, but more like a p orbital shape because when it's hybridized. And then we call this sigma bonds. It just looks like a sigma, because you know sigma is, I think it's a Greek word, yeah, Greek letter. So it's a sigma. It just looks like a sigma. That's what we call the sigma bonds. But like I said, it's not. If it's not sp3, maybe it's sp2. Meaning, like I said, you have still 1 electrons on the p, right? So to pair up this one, you're going to have this one. Meaning, because of the shape, when it approaches to an approximate distance, they're going to have, not in the center, because it looks like a dumbbell shape, so you have a more chance to link on the top and bottom. This is why we call this one pi bond. Okay, so this will make 2 pair of electrons making a covalent bonds. So this is a double bond. Okay, so double bond has sp2 hybrid orbitals making a sigma bond between these two right here. It's still there, but you also have what? You also have 1 pair of